So I think this is about all the people that we expected. So if you're okay with it, I can just start. Feel free to get some water if your throat is dry or anything. And that's so the title of my presentation is I'm going to talk today about different educational data mining techniques to kind of like assess self-regulated learning processes in the context of computer-based learning environments. So the algorithms I'm going to talk about is to process unstructured data, like text-based data. So basically how I wanted to start is just to refer back to the field I'm going to talk about, so educational data mining. Educational data mining is a fairly recent field that just came out, or just like, I guess, came like a little bit more official about like 3 to 5 years ago. It's a field that's concerned about creating analytical techniques to analyze multi-level data. So data, for example, that occurs for a single student over multiple points in time, and data that reflects how students interact with a given context, like features in a computer-based learning environment. And this type of data also is taken from different kinds of educational settings, so ranging from schools to universities to one of our studies, like looking at Twitter feeds, and gathered in the context of computer-based learning environments. So I included a number of references and kind of like resources and stuff, since this was meant kind of like as a workshop demonstration. So what I'll do is I'll actually post the slides on the website so that you can have like access later on. So some of these references are actually some of the important contributions that just came out in the field a couple of years ago. And there's also a number of professional associations that kind of define educational data mining. So there's the International Education Data Mining Society and the User Modeling Inc., which are nice resources to go to. There's a conference that was created just recently, so the International Conference of Educational Data Mining, which this year will be given right after AINet in Memphis. So if you're interested in this, that just started in 2008. And a little bit more while back was the User Modeling and User Adapted Interaction Conference. So this one is still ongoing. And there was a journal that was created on that topic, so the Journal of Educational Data Mining, that just came out in 2009. And if you're interested, the Pittsburgh Science of Learning Center has a data shop where you can actually access data sets. Yes.
And all of the lead students can apply for this, and we can provide funding based on the best proposal. So please, if you are interested, let us know soon. The call for that, though, isn't up yet, is it, Gary?
The summer conference is giving during the summer.
I don't think it'll be
I don't think it's open yet.
January is when it's supposed to be announced. Yeah.
But if you are interested, those workshops are
Yeah.
really good. Like they give you like a lot of hands-on experience in trying to model different types of data and building applications and such. And it goes on for I think a week or so. So again, the slides will be posted on the website, so you can just click on this hyperlink to go and see it for yourself. So kind of like the main challenge that we tackle using these techniques, and I'll just read a quote here that was written by Shu and Zapata Rivera in Adaptive Educational Systems. Adaptive educational systems monitor important learner characteristics and make appropriate adjustments to the instructional medium to support enhanced learning. So really the challenge of accomplishing this goal, and it's a challenge that we face in our own research, depends largely on accurately identifying characteristics of a particular learner or group of learners, whether that be like different affective states or SRL strategies, and then to adapt the system to basically select and then present content to the learner that's the most appropriate to their needs. So this challenge we face in numerous projects that we've undertaken in our lab, but I think it's also a topic that might be of relevance to your own research as well, like for example in the context of a meta-tutor, like how can you assess whether or not the notes that the students write are actually appropriate or inappropriate, and then make adjustments through the pedagogical agent to support those learners. Or in the context of looking at tweets with the project I'm doing with John, like how can you actually assess, by analyzing the text, whether or not students are expressing different types of emotions. I'll just move on. So there's two main applications that we focused on looking at these techniques. So the first one is user modeling, where we're basically interested in trying to build kind of like a representation of what the students know or is able to do, and embed that representation in the system so that we can assess the students while they're using the software. And some of these applications might be able to assess them on different learner states and characteristics, whether they're using certain cognitive and metacognitive strategies, and as well as facing several types of problem to basically intervene when it's most appropriate. And the other applications actually generate recommendations. So after you've assessed the learners while they're using the system, like how can you then decide what kind of instruction to provide to the learner to kind of like address that problem. So today I'll be talking about a number of techniques that we've kind of looked at. The first one was visualization, so trying to build visual or graphical representations of the data that we collect with the hopes that we could present that data to the learners and that would help them in acquiring some of the strategies that we expect them to use. And also using it for the purposes of research as well, so trying to model the different sequences in which strategies are used, for instance. Another algorithm that we use so far to analyze the text is clustering. So in using clustering techniques, we're interested in looking at if different data points are similar to one another on a certain characteristic. So for example, one of the things that we study are the notes that they write while using the software. And we're kind of interested in determining whether or not we could computationally kind of determine whether certain notes are kind of like more semantically similar, and to kind of like group them in like according to certain teams, but doing that like automatically using those algorithms. And the other one is classification. So this one we're pretty interested in, but it's something that we're going to kind of like look at in the future. Is kind of like, well, if you've collected like a huge amount of data and you've kind of like labeled these data sets on a particular characteristic. So let's say that you have like notes that pertain to the use of certain strategies, and you kind of like labeled them as like, well, 100 of these notes are appropriate and another 100 of these notes are inappropriate. Like what classification kind of like is meant to do is like once the learner actually writes a new note, like can you use all of these examples to kind of like reason by analogy, saying that, well, since this note is similar to like, well, 50 of these other notes that seems to be appropriate, then maybe this new note would be appropriate as well. And it's kind of like getting at that, but with like doing it like automatically, like through software and such. So some of our contributions in this area has been to apply the visualizations to model the use of cognitive and metacognitive strategies in learning through historical inquiries and using different coding techniques. So I'll talk a bit about that during my talk. And the algorithm that we've used to examine clustering is the k-means algorithm. And we've used this to model the use of cognitive activities, so the strategies that they use while writing notes with the software. And we use cosine similarity as our index measure for the similarity. And the classification algorithm that we looked at is the k-nearest neighbor algorithm. And we've used this to basically model the same types of strategy and using the same index. So the example that I'll be referring to is the data that I've gathered with the meta-history reasoning tool, although I believe that those algorithms would be applicable to any kind of other context. So the meta-history reasoning tool is a computer-based learning environment that was designed to enhance learning in the domain of history. So we've used a model of different cognitive and metacognitive activities that are domain-specific and that are used to learning through historical inquiry. So while the students are actually using the software, they try and figure out why a certain historical event occurred. So, you know, could it be like, some of those examples of different topics could be like what was the most important cause for the Second World War? In our case, we've used the Acadian deportation. We've done a number of studies evaluating different features of the software, such as the training module and the annotation tool and the explanation palette. So the data that I'll be using, the example, will be the data that we've gathered from the annotation tool, where they write notes. And I'll show you an example of this as well. And the conceptual framework that we kind of guide I would say our entire research has been the Forer process adaptive cycle for building adaptive technologies, which is a big mouthful for saying that we basically are interested in distinguishing what information we want to collect from the learner, then to analyze it in real time, to be then able to select what instructional method we want to provide through the system and to deliver that through different mediums. Whether that be like a pedagogical agent or a video or just changing documents, so on and so forth. So this is the actual picture of the model, and I won't go into the details of all the components and the processes and such. But we focused so far our research on only like a little subset of the strategies that they use. So we're really interested right now in looking at how they evaluate the credibility of certain documents, judging whether or not that source is trustworthy or not to gather information. We want them to basically formulate an argument in favor of their explanation for the historical event. And then we want them to corroborate and contextualize that evidence, which is a fancy way of saying that once they've identified factual information, we want to train them to look for different information that's similar or different to build a better argument. And then we want them also to kind of like infer some of the details that surround the historical event. So where it took place, when it took place, what were some of the attitudes or the motives of the people that were involved, and so on and so forth. I kind of like to gain a better understanding of the event. So this are like kind of like a picture of the different layouts of the meta-history reasoning tool. So the students first use the training module, where they study examples of the strategies that we want them to acquire. And here is like the self-explanation prompt window, where they actually elaborate on those explanations. They try and infer their purpose and rationale and so forth. So after they've used the strategies that are shown like in the training module, we're actually supporting them to use those strategies to come up with their own explanation for why a certain historical event occurred. So to do so, they use the inquiry module. And the data that I'll be showing to you today was obtained from the annotation tools. So they write notes with the annotation tool to kind of like argue in favor of their explanation. And the annotation tool, the design of it, the note-taking template, is actually tailored towards the use of each skill that I mentioned earlier. So evaluating the trustworthiness of sources, and then gathering, corroborating, contextualizing evidence. So the first data mining kind of technique that I wanted to talk about was using the visualizations. So in the visualizations are actually a graphical representation of the log file entries I gathered. Oh, thank you very much. From the system. And we're kind of interested in using these visualizations to kind of replace right now the examples that we have in the training module. So we want to build like visualizations that exemplify the use of those strategies, and in the hope that later on we'll be able to actually embed those in the system so that the students can manipulate them and so on and so forth. And we've been using CMAP's tool, which was the same as Geneviève Gauthier, which was a past student in our lab that she used to kind of like depict different steps in diagnostic reasoning. So basically, our aim in using those visualizations is to represent the information in a meaningful manner and to basically inform the creation of our learner model. So by considering in which sequence the different events occur, looking at the different codes and so on and so forth. So I'll show you an example of what these visualizations look like. So we've been kind of right now kind of like experimenting with different versions. This was one version that we came up with. So let's see if I can zoom in on the little box there. A little bit more, too much. Okay, so can people actually read that?
Maybe you could read it for the older folks in the group. I can't read it.
Can I read my white cane? Yeah.
All right, well, kind of like this is an actual example of an annotation that one of the students wrote. So evaluating the trustworthiness of the source was the first strategy that that student used. And she basically looked at, or she or he basically looked at the document and wrote that this source is trustworthy because Cornwallis was the governor of the province at this time. So Edward Cornwallis back in 1755 was the actual governor of, well now, back in days it was used to call Acadia. Nowadays it would be like the Maritime Provinces in Nova Scotia. So he was the governor at that time, and she said, however, he may have had some bias of the situation, which, I'm sorry. The source is trustworthy because Cornwallis was the governor of the province at this time. However, he may have had some bias of the situation which cannot be overlooked. So basically, while they're using these strategies, they're writing these notes and so on and so forth, and all of the notes get saved and displayed later on to kind of like give them an overview. So what we're interested in doing is kind of like building those representations to kind of like show to new students like later on what those strategies kind of look like and how they're used. So in explaining the historical event, for example, she said, well, the most important cause for the Acadian deportation is the Acadian deputies' refusal to swear the oath of allegiance, and so on and so forth. Another example that we come up with, so this shows the actual content of the notes, and this one is how we actually code the data. And I actually prepared handouts, which is in my bag. I can pass that along.
So Eric, are you talking about these annotations and the visualization strategies as one, ways that you're coding the data, and then are you doing the same approach that Genevieve did, which was sharing their own representations with the learner to see whether in fact that's what they were thinking? Or are you using the visualizations just for coding, or are you going to use it for training? So there's many ways that you could use it, and I'm just wondering which way you're talking about right now. Just for coding?
Oh, okay, well, there's,
Yeah.
I guess you could probably like use them for both. Like, what I found is that like it's helpful for coding because like when you have like notes, for example, that combine like textual and visual information, like for example like the explanations, you can use like this little feature that embeds it so that you can summarize what you're coding, and then you can kind of like go back and forth like with less detail and with more detail. So I found it like a good way to code and capture like the sequence of the different like events as they occur and stuff. But my primary focus would be to use some of these annotations and kind of like to develop it in a way that I could show like the actual strategies, like how they're used, and kind of like show that to the learner.
As a training, to say these are these strategies, train them how to use these different sources of data, and so that they know how to evaluate trustworthiness, what's a primary source versus. So it would be a training tool, and then they would then inquire on their own text.
That's right.
Yeah. Okay.
So they would see like the visualizations like during the training module and stuff, and after they've studied these different examples of how the skills are used, and they could use the inquiry module to actually apply those skills to come up with their own explanation and such. So that's about all I wanted to show like in terms of like the visualizations. Like again, like I have like links to CMaps and stuff if you're interested in playing around with the software. In my own experience, like I found it like a little bit more extra time to do the coding and stuff, but like it's a nice way to kind of like picture information and to present different things. Like I use like the annotations to kind of like code like the types of strategies that are used and the different properties, like if they're used appropriately or not. And all of those details about the coding are shown in the coding scheme that I just passed along.
Can you just read that little sticky? I didn't get that.
Yeah, so this is just an example of how she evaluated the trustworthiness of the source. So this was the annotation that I read earlier. So the type of strategy that she engaged in was the author's position, which is a subtype of evaluating the trustworthiness of sources. And she attributed the authorship of the document to Edward Cornwallis, which she could have actually attributed it to also the person that's transcribed the document, so the secretary, which was, to be honest, I forget the name. It was, anyways, there's another name. And she also recognized that there was a certain form of bias. So in our past research, we've actually, in analyzing the notes, we've actually looked at the way that they kind of like evaluate the credibility, and most students tend to argue solely in favor of how their source that they use is most credible. So there tends to be like a little bit of a confirmation bias when they actually go through these documents and such. So if there's are there any questions at this point?
So what you're visualizing there is like an argument in a way, right?
Mm-hmm.
The way students argue that this is true and this is supported by whatever.
Yeah, it's very like reasoning with the goal of like building an argument. So they come up with their claims, like the explanation they choose for the event, and they justify their claims based on the factual information that they obtain from the documents. And some of the strategies like contextualizations are just like built on those arguments. Like for example, well, if you gather factual information, you'll try and infer some of the details that surrounded where that factual information was obtained, at what time and by whom, and so on and so forth. Any other questions before I go on to the clustering technique? Okay, so I'm actually not plugged into the power. Well, I'll have to try and give the presentation. Oh, okay. We're back. Okay, we're good. And I just had like a little power issue. That's good. Disregard that. Okay. I'll just come back here. So the next part I wanted to show was the use of the different clustering and classification algorithms that we've focused. So I'll focus on clustering first. And clustering actually involves like calculating, first of all, processing the text that you obtain like through the notes and representing that text as vectors. So like a vector is kind of like a table where each word would be a cell within that table. So what we actually do in clustering is that we calculate what's called the cosine of the angle, which is kind of like numeric, it gives you like a numeric value of how much words tend to co-occur in between two notes. And it's basically interpreted like a correlation. So if you have like a value of 0, your note would have absolutely no match. So there's just like no words that tended to co-occur between both notes. If you have a value of 1, it means that it's a perfect match. So the notes were identical, basically. So we use this cosine value to process it through the k-means algorithm. And it's a shame that Bob Bristol isn't here right now, because he would really enjoy to kind of like explain to you all this mad stuff. But you know, I'll spare you most of the details since it's 12. It's a Friday.
But Eric, this is very cool. Can you just describe how, like, did you use every word or just those with high frequencies that how did you determine, like, there's a lot of text, I'm sure, that you're mining, like, so how do you pick?
Well, I can show you the software that we use and such. Like the k-means algorithm is just like how the software actually like groups up all the notes together based on how similar they are. And you can identify like themes across your notes, like for example, whether or not some of the notes talked about one aspect of the document as opposed to another. But we use the RapidMiner software, which is freely available, and I've included a hyperlink to that website, so you can see it for yourself if you're interested. Okay, so basically there's, here I'll sit down for this part. I'm crouching all the time and it seems like I'm talking to my computer screen. So the RapidMiner gives you like a different operators, and each operator has a specific role that it transforms the text with. So the first operators I include in here is basically to import the data. So you can import the data using different ways with RapidMiner. So there's some operators, for example, for web mining, which is shown here. So if you're interested in doing research with different web pages, you can actually define like a set of URLs, and RapidMiner will go and get those web pages to process it. What I've done is basically just enter it as like as a separate document, which is shown here. So I've just basically added each note, well, 3 different notes that different students wrote to do the analysis, just to show like an example. So the first note was, for example, in the first paragraph, the source states that in a letter from the French inhabitants of this province, they asked us to grant they shall not be obliged to take up arms in case of war, even should the province be attacked. And there's different operators too. Like if you want to just type in like your notes, you can create like a separate document, like I just did. You can load the different text as .csv files or .excel spreadsheets and so on and so forth. So that's basically like the different options that you have for loading your data. The next operator is the operator that we use to actually process the documents. So there's a sub-process within this where it's responsible for basically analyzing like all the notes and such. So the first operator basically transforms your text and transforms it all to lowercase. to enable you to match like different words. So for example, if you have like Canada with like a capital C, so it'll reduce it to Canada with like a lower c, like a lowercase c. And the second processor is to tokenize each of your words. So this, because the notes or the text actually appears like as sentences in this example. So this algorithm will actually treat each word in that sentence as a separate unit, so that you can match the words to one and the other.
Within that sentence.
Mm-hmm. And this operator is one where you can replace tokens. So the token is actually the cell within your vector. So a token is like separate words and such. So the replace tokens, like I've just used it here, I've included like replace every instance where a token is I'm to I am. You can use this library to basically, like if you're interested in doing sentiment analysis, for example, you can come up with a library of different tokens that are kind of like words that are emotionally relevant. So let's say you have like hate, hated, or happy, or happiness. So all of those words you can basically replace with like positive emotions or negative emotions, so that you can kind of keep track.
You can go in there and then assign, is that what you're saying? You can group all those and assign it as, like kind of change it to be one vector that you're analyzing instead of 18 or whatever. 18 words for happy. You can have 18 words that mean happy and count them like 18 times, right?
So that, you know, when you're doing your analysis, like each word is now separate, so it's like a separate token within your vector. And basically, like let's say that you have like words that dictate like I'm happy and you know I was really sad that day. Then you can replace those words inside your vector with whatever variable that you're interested in studying to kind of like keep track things like how frequently they tend to occur, how common they are across all the nodes, and so on and so forth. And I'll show you an example of how that data looks like.
Is there any limitation on how much text you can enter into the, like at a time?
Well, the most that I've tried was the actually some of the tweets that we've gathered from our data.
But they're short, or did you put them all? Like.
Oh, well, there's no limits in terms of length. Like the only limit that I would think of would be like your CPU processing power, but you would need like really large amounts of text.
Can you assign a weight to the different meanings? So for instance, somebody says, I'm sort of happy, I'm really happy, I'm ecstatic, you could...
Yeah, there is a way to assign the weights. I don't recall what operator that is actually. Yeah, I think it does an option, and I'm not sure at what step would you include it. But there is a way to include that in the analysis and stuff. And I think there's a section on it in the user manual, which is on their website. John, you're good?
Yeah.
One of the other operators is to filter stop words, so all your articles and conjunctions, things like the, and, a, to kind of strip it away, so that you just get at the words which are actually more meaningful. You can filter also tokens by length. So let's say that you want to, like all the words with less than 3 characters, you want them taken out from the analysis. So that's another operator you can use. There's a number of different stemming algorithms that'll basically take your words and reduce it to the common root. So things like Canadian, Canadians with the S, or Canada would all be reduced to their common root, which would be can. So that you can kind of like account for different variability in words and different ways that they can be written. And there's also the option to generate what's called n-grams. So let's say that you want to run an analysis and you kind of like want to know what's the context in which a word was used. So the n-grams will bunch like 2 words, like Eric is Canadian, and it'll include in one vector Eric and Canadian, so lumped up together. So that when you're actually looking at your word list, you can kind of say, well, oh yeah, like all instances of like happy words tended to be associated with money, for example. So it gives you like an idea of like the topic of the note and like the context that a word was written in. Okay, so that was basically for the processing